So here is the product process matrix slide that we wanted to talk about. Let's focus on this very colorful matrix here, the matrix. The matrix here is the kind of MBA slide matrix. What I mean by that, that the axes don't have numbers, okay? They basically have a low and high, low and high. And you want to populate that table with some some dots, and in this case, the dots are the squares here, right? And basically, the idea is to say that when this x-axis is high and the y-axis is high, what happens at this corner around this region? We're not going to be so specific to give the coordinate, the numbers, but we're just saying that when in general, right, product variety is high, your company wants to make high number of different brands and models to offer to your customers. You want to. So the intention is you want high product variety, and you also have high process flexibility. This have high process flexibility, right, is a little bit like what you have already and also what you can do pretty much in the short term. Factoring in what you can possibly do in the short term. Can you change? Flexibility means change. Are you able to change your process? Is your process adaptable to changes in the model and specifications? Okay, so if both are high, so it means we want to make low standardization, high repeatability, one of a kind, right? One of a kind, and a low standardization, not high repeatability, but high variety, right? Because standardization means you repeat the same, but so this low means don't repeat the same. Every single item is different. One of a kind, down to one, down to the volume of one. I mean, you can't go to zero. Low volume, right? So basically, for example, t-shirt printing on demand based on individual submitted picture. You submit a picture, I print it, and I give that to you. Even if you order just one unit, I can do that. So can you do that or not? Yeah, so they can, right? Process segments loosely linked. Why? Because this is from what I know, from what I hear, is a laser printed machine, a laser printing machine. So instead of printing on paper, they print on white t-shirt. That's all. And this laser printer is of course sophisticated, expensive, and can print one picture for one shirt. 1,000 pictures, 1,000 shirts. One picture print 10 shirts, no problem. One picture prints 50 shirts, not so much a problem. One picture prints 100,000 shirts, not for this printer. Too expensive. Variable cost too high. You get the idea, right? So if I'm serving customers, submit one PDF, one JPG picture, right, and choose the size of the print of your T-shirt. General background, gray color, white color, those colors, right? Then okay, submit, pay their money, and I will do it. So how should the company arrange their process? So this is the element in that corner. It says job shop, and it says commercial printer, right? So I wasn't looking at this when I give the example. So it says commercial printer, architecture firm, one project at a time. Basically, if you're project based and the project time is not very long, 1 week, 1 month, then basically it's a job shop situation. Okay, so you should arrange as a job shop. Like I said, submit one JPEG picture, print one shirt, 10 shirts, no problem. I will do it. Print 1,000 shirts. Now you might wonder, instead of giving you 1,000 pictures, I give you one picture, and then you keep printing 1,000 shirts. What's the problem? The problem is the 1,000 is sprinkled all over 1,000 customers. Or if you have one picture, one shirt, then it's like 1,000 different customers. They submit their picture at different times, stretching out throughout maybe 1 week, right? Then I process each time with the laser printer. No problem, totally okay. And all the 1,000 customers will be happy. Yeah. Some may want 5 shirts of the same picture, fine, no problem. But what we are talking about in 100,000 shirts with one picture is that the customer, there's only one customer. That customer wants it like immediately, but reasonably immediately, like 3 days, okay, 5 days, 7 days, fine. But that would give a very strenuous situation to our printer, right? So it's going to keep doing that. Not only that, it cannot, even if we operate 24/7, it cannot produce 100,000 in time. But the necessary cooling down period, right? Because it get overheated, we're going to change the toner, whatnot. It's going to wear out this laser printer very soon. And so when my genuine customers who submitted one picture for 2 shirts, one picture for 1 shirt, they will get annoyed because they don't get a t-shirt until 2 weeks later, when normally it's 1 day. So I'm now abandoning my customer and serving this big one-time customer who is probably also one time and never going to come back again, right? Because I didn't do a good job. Right? So it will be a mismatch. So if you have high variety and low volume, high variety typically goes to low volume, then you want a job shop. Let's move down all the way to the other extreme for easier understanding. So if you are mass producing one picture, many units, like for example a best foot forward run. So NTU prints, example, 3,000 shirts. That's like considered volume, and don't need variety, just the NTU logo and whatnot, finish, right? So same design, massive printouts, massive production. So product variety, low until there's only one design, okay? And the supplier that we talk to will need to have process flexibility that is continuous. That means it's like after laying out the t-shirt, it gets flattened, right? Then it gets sprinkled with water to prepare it for, color, whatever it is, right? And it is automated. It is rigid line flow because it is very, how do we put it? Like the standard factories that we have in mind, right? Like after this step, next step, next step, next step, right? So it is the imprints and everything, they're all very mechanical, interlocking each other. One step leads to another step, line flow process. Right? Process segments tightly linked because after finishing the pressing of the shirt, next is the printing of the red color, then the printing of the blue color, then the printing of the green color, whatnot, and then finally a heat treating process to whatever, burn in the colors, and then whatever it is, packaging. So continuous it's like a very rigid flow. Can we change it? The can, anything is possible, right? But the can is very reluctant can. It takes a long time with a lot of money that you might as well set up another factory. So that kind of can is not what we are talking about. So answer is cannot. So when I say cannot, it's like, what do you mean cannot, right? Anything is possible. That's true. That's true. But we're saying that you are the owner of this factory with the conveyor belt, right? So all the t-shirts are rolling, ka-ching, 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 and you're talking about changing it. Changing means downtime plus new machine, and these kind of machines that are now expensive and they need to run it. That means once you install, you go to configure, then test run. Only when test run is successful, then you can mass produce. So the downtime means you cannot sell to customers. Money loss. Right? So, and then the run-in extends the downtime. And after the change, your customer may not want variety, right? So basically problematic. So continuous flow. So in the extreme, we have not t-shirts, but down to liquid, right? Every water droplets will be processed. So Singapore has this NEWater, right? NEWater that is basically taking wastewater, filter, right? The mass, big bulk filter, chemical filter, organic filter, whatever it is, filter, then adding chemical treatment, quality tests, whatnot, and so on and so forth, right? So it's a piping process. There's no clear stages because they're not discrete entities, but every droplet goes through very distinct steps of processing, right? And it's continuous flow. So the example given here, oil refinery. And if you go to Tuas, yeah, somewhere near Benoi sector, there is oxygen manufacturer, gaseous production for medical use, right? For various use, they need those oxygen tanks. And how do you get the oxygen in the first place, right? Yeah, so you will need to get the oxygen in through various pipes and filters, or the raw material, right? So to feed in, then you may need to add some small amounts of elements of other gases to make it, certifiable or matching the standards, either for medical use or for industrial use, for soldering use, or whatever it is. You need to kind of add a little bit of right mix to meet the industry specification. So same thing, continuous flow. The oxygen doesn't go through buckets, right? They don't go through a tank, then this tank move to another processing step. They don't do that. They just have continuous pipe. And then out comes the filled tanks. So that's the continuous flow concept. Also, you have pipes. And if it is more discrete, like the t-shirt I was talking about, then it will be line flows. So connected line with conveyor belts. So basically these two are quite similar because the conveyor belt can carry a variety of weight up to a certain extent, right? And can carry shirts of different sizes, small, medium, XL, XXL, and right. So it doesn't mean that XXL you have to have a different line. It can be managed by the same line that handles medium, small, extra small, right? So you can do that. And so that will be like moderate levels of variety. Yes. In production, we do call those t-shirts same design, everything, but different sizes, different products, different SKUs, stock keeping units. Imagine you go to the shoe store, right? You buy a shoe. Of course, you test whether the shoe matches your size. And when you found a match, let's say your size is, 42, you really like the design, you like the color, do you have 42? We ran out. Would you buy 43? Would you buy 41? You don't, right? Because too loose, too tight, they will cause discomfort, even injury to your feet. So you don't do that. That's why they are considered different items. 42 ran out, 43 hasn't, 41 still has stock, but you're not going to use them. So it's different product, right? You're not going to pay money for 43 and 41. So that's why here, line flows, different products. So don't imagine like you're making canned food and t-shirt all on the same conveyor belt. Not like that, all right? But when we say few major products, it means slight variety in terms of maybe a small metric, like the size of the t-shirt, okay, like the color of the t-shirt, maybe, okay, possible, right? So then you can have the line flow. Now, then finally, of course, the last part is the in middle ground between one piece at a time with huge amounts of variety and continuous huge volume, but one variety. Yeah? Is this middle ground here. Middle ground here. So batch. Batch is like you gather a few quantity together, not super huge, but not one. So then you find it economical, cost effective to process this batch of raw materials into final goods. So that would be um, again the way it looks also. For example, if you go past bread shop, in Singapore there are a few of those. I think they own it themselves. They make the bread on the spot in the shop, right? And so when they bake, you can see the oven. There are trays, right? Typically maybe a meter by meter, right? So they put the buns, everything inside, and then they bake in batches. They produce in batches. They never make one bread. They never make one brand. They have decent varieties, right? They have almond chocolate. Speaking of which, I'm really hungry about that. They have almond chocolate. I don't know what do you call that? Pizza taste, chicken sausage, right? So they have quite an attractive variety because if you don't have variety, people don't stop by and buy. Especially those bakery shops near to high traffic area like MRT and all that, right? So you know attract a lot of uh, taste buds to come by your shop. So you want to offer quite a number of variety. Each variety is not going to be high. So you're not going to have cheese buns, 1,000 units of them, thinking you will sell 1,000 per day. For Singapore, I don't think that's possible. Okay, not for a day. Chicken sausage, 1,000, no, right? So you're going to have like 10 pieces here, 10 pieces there. When you sell out and time is still early, you can make another batch of 10 chicken sausages, right? So that will help them to manage costs and reduce the waste. So that is the batch mode that they are in. Now, you guys in studying this course, come to class as a class. Actually, the class is a batch. So from Nanyang Business School perspective, there's no one-to-one tutelage. You're not gonna have, arrangements to meet me one at a time. I will talk to you this, and then we meet the same, and then the same for the second, third student. No, not one to one. Neither is this in mass production mode, right? Line flows or continuous. For humans, we'll have lectures, right? One to many webinars, 1 to 600 students all at once. Nice, scalable, but bad for education because you don't get the chance to ask questions. Yeah, because you just sit there and one-way traffic, right? So the instructor, lecturer just lectures, and that's why they have this title called lecturer. Maybe they should change the title now to just interactor or just instructor. I don't know. Yeah, but lecturer, the title originates from lecturing, right? Yeah, so it's one to many, and that's more like mass production. So one class only, one class, 600 students can listen to the same lecture, no questions to be asked, right? And then that's it. So very, very scalable if the society accepts it. But of course, increasingly, that is not recognized as a very effective. Now, that's very efficient way of doing it, but not effective way. No. So as a batch, right, we are in a kind of moderate size classroom where, of course, instructors can talk and students get the chance to raise their own questions. And of course, everyone's question is different, everyone's doubt and confusion is different. And so you get the chance to interact and clear your own doubt, which is like printing your own t-shirt with your own picture. You see that similarity? If you get the chance to ask your own question, you get to print your own picture on your own t-shirt, right? And that's done in batch, not for 600 students, but for a class of 30, 40 students. Okay, so that's the way it goes. Now, if you want high variety and you are, able, you have the assets, the laser printer and whatnot to do that, then you should be operating as a job. Now, of course, can we purposely not do that? Sometimes the purposely means we didn't know, didn't think, that's why I end up doing that. So what if the company doesn't operate on these squares? In short, this matrix says, if you're on the line, on the diagonal line, you live. Okay? If you are off the diagonal line, you cannot survive. You will close shop sooner or later. Better be sooner. Okay, so that's the simple summary of this chart. If you're on the diagonal line, you live. Otherwise, you cannot survive for different reasons. Opportunity cost, some of market cost, but cannot survive. Okay, so very, very simple, illustrative way to check yourself. Am I aligned? Am I practicing yoga? Am I practicing Tai Chi the right way so that the flow in my internal organs is nice, right? I feel the zen, the qi or whatever it is, right? Okay, so the idea is if I am having high variety, I am offering my customers submit one t-shirt at a time, one picture at a time. You can print one shirt, two shirts, 10 shirts. But then I also allow my customers to submit 100,000 shirts. And I'm having a laser printer. So I'm basically forced to be here, right? When my customer wants 100,000 shirts and I'm having this, high flexibility situation. Then what happens? Basically, I will not survive. I will not survive because I might either not serve these 100,000 customers, then I will have opportunity cost, right? Because this is very lucrative. One customer gives me $10,000 profit, then everything. Right? This one customer gives me $10. I got to serve 1,000 customers, then I can get right. So I would lose the opportunity. So I cannot be entertaining. I don't need to market to them, right? So in fact, I shouldn't deal with them. I should just focus on this. Okay. And suppose the other way around. I'm trying to mass print. I serve businesses. Okay, I serve election candidates, parties, right? I serve businesses. I'm printing t-shirts massively. Minimum order 10,000 t-shirts. Minimum pamphlets 50,000 pamphlets or more. Then I give you good cost and everything, right? So, but then if I choose to operate here, if I'm only having laser printers that is meant for one picture at a time, for one t-shirt, for one pamphlet, then it will take me long time to print because it's not designed for continuous ka-ching, 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 like 5 frames per second. Laser is fast, accurate, precise, and nice, high quality, but relative to the high speed mechanical mass production printing process, it's super slow or super slow. So the thing is, I will not be able to support that. If I forcefully use the printer to produce 100,000 of the same size, I am not exercising the flexibility by changing pictures that my setup offers me. Right? I could have changed to 1,000 different pictures, but my customer didn't want, so I didn't use this feature. Remember the waste? I bought this feature, but I didn't use it, right? And then capacity, I wouldn't be able to produce in time. So I would have to say sorry to my customer. You might say it's printing very fast, but yeah, because it is also not having the kind of big volume reservoir of toner and what, I got to stop it and change it, right? And it is meant for short, small volume printing, 1 to 10. And you are, and therefore the design, the materials, even if it's branded HP, will be small screws, small plastics, everything will be small. That means the wear and tear is very severe if you use it in a very um, heavy duty fashion way. So totally outmatched. You're going to be saying sorry to customers. You're not going to earn a lot, right? Because your primary attractive feature of offering variety is not used at all, right? So you're like talking to the wrong customer. So you're going to go out of business very soon if you repeat this again and again. And this is the main lens. I like to look at them as like camera lens, because if you wear a red filter, you see things in red. If you wear infrared kind of thing, you can see infrared. Right? If you can see through, if they have an X-ray kind of vision, then you can see through. So this lens allows us to see internally, process-wise. Are you matching your business strategy and your customers? Right, yeah. So that's the idea. So here is an illustration of job shops versus assembly lines. And basically, assembly lines is the typical image you can think of, ka-ching, 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 right? So conveyor belt, that kind of thing. Huh? And job shop is more like many products with their own distinct production routes. Product A might follow the red route, ding, 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 like 1, 3, 4, 2, 1, out. Okay. Product B, still produced by the same team of 4 machine or 4 people, gets routed this way, 1, 4, 3, 2, out from 2. Just an example. It could be that 1, 2, 1, 2, 4, then out. Various different steps. So you can see that when you repeat the steps or out of order, out of sequence, or whatever it is, it can increase the variety. It can increase the variety, but it doesn't increase the stations. So that's kind of a clever way to kind of hit an in between, all right? And if you do that, then you can increase the variety without necessarily increasing a lot of costs. So that's again an optimized way of looking at it.